Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. So in today's class, we will be talking about pointers and two-dimensional array. Now let us consider an array declaration arra underscore a 33. So here I have declared an integer array with 3 rows and 3 columns. So altogether this integer array will have 9 elements. Now here the significance of the declaration is that the array name arra underscore a itself marks the beginning of array definition in memory. That means array name itself is a pointer value. Now here we have a problem. The problem is that data is of multiple dimension whereas memory is of unidimension. So in order to ensure that the data is represented in memory or stored in memory, the multidimensional data is to be broken down or decomposed in terms of unidimensional representation. So here we'll use a decomposition rule that two-dimensional array with n rows and m columns can be decomposed into n one-dimensional array with m elements. Again here I'll repeat it. Two-dimensional array with n rows and m columns can be decomposed into n one-dimensional array with m elements. On decomposing the two-dimensional array, now what we have is we have three one-dimensional arrays. So now here we will have four notations for address. arra underscore a that marks the beginning of the entire two-dimensional array. arr a underscore a0 that marks the beginning of the first row of the two-dimensional array. arr a underscore a1 that marks the beginning of the second row in the two-dimensional array, and arr a underscore a2 that marks the beginning of the second row in the two-dimensional array. So here we have four notations for address. First, arra underscore a marks the beginning of the entire two-dimensional array. arra underscore a 0 to 2 marks the beginning of the individual rows of the two-dimensional array. So now in order to access the elements of the two-dimensional array, so let us consider we are trying to access zeroth element of the zeroth row in the two-dimensional array, that is arra underscore a 0 0. So we are trying to access zeroth element of the zeroth row. So in order to access zeroth element of the zeroth row, I need to create a displacement of 0 from the base address, that is arra underscore a0, because we know that arra underscore a0 is the base address of the zeroth row. So if I create a displacement of 0 from the base address, I will be capable of referring to that particular array element. So arra a00 can be represented alternatively as asterisk of arra underscore a0 plus 0. Now on generalizing, if I want to access jth element of ith row, then we can use the notation. So in order to access jth element of the ith row, we can use the notation asterisk of arra underscore a I plus j, because arra underscore ai is the base address of the ith row, and from that base address I am creating a displacement of j positions. So here, in order to access jth element of ith row, I can use asterisk of arra underscore ai plus j. Now using the deduction from one-dimensional array, so if you remember, in case of one-dimensional array, we have come to a conclusion that arra underscore ai can be replaced with asterisk of ptr plus I, or it can be replaced with asterisk of arra underscore a plus I. So now using that particular deduction, so arra underscore ai can be replaced with arra underscore a plus I. Okay, so which implies arra ij. That means in order to access jth element of ith row, we will be creating displacement of rows first, then we'll create a displacement in column. So that is equivalent to asterisk of arra underscore a plus I plus J. So this is a very important notation that one needs to remember in case of two-dimensional array. Now let us consider pointers and three-dimensional array. Now let's consider an array declaration ARR A333. So here ARR A underscore A is a three-dimensional array with 3 layers, 3 rows, and 3 columns. Now, as in case of one-dimensional array and two-dimensional array, the array name marks the beginning of array definition in memory, that is ARR A underscore A is a pointer value. Now, since we have already discussed, as in case of two-dimensional array, memory is always of unit dimension. So whatever may be the dimension of the data has to be broken down in terms of unidimensional representation. So here we have 3 layers, 3 rows, and 3 columns. So now what we need to do is we need to decompose this three-dimensional data set in terms of unidimensional data. So if we decompose it, in order to decompose it, we'll follow the decomposition rule that three-dimensional array with k layers, n rows, and m columns can be decomposed into k two-dimensional array with n rows and m columns. Right? So this is very easy to interpret. So three-dimensional array with k layers, m rows, and n columns is decomposed into k two-dimensional array with n rows and m columns. Likewise, a two-dimensional array with n rows and m columns can be decomposed into n one-dimensional array with m elements. Further, it implies three-dimensional array with k layers, n rows, and m columns can be decomposed into k into n one-dimensional array with m elements. That implies here, if we decompose this three-dimensional array, then we'll altogether have 9 one-dimensional array, right? 9 one-dimensional array will be formed after decomposition of this three-dimensional array. So this is the way how decomposition will be done. Now here is ARR A underscore A 0, 1, and 2 will be representing the address of the individual layers. In case of two-dimensional array, it was representing the address of the individual rows. So here it will be representing address of the individual layers. And ARR A 0 along with the row index will be representing the base address of the individual rows. So ARR A underscore A 0, 0 will be representing base address of the 0th row in the 0th layer, right? So that is the way how interpretation will be done. Now here, in order to access 0th element of 0th row in 0th layer, so in order to access 0th element of 0th row in 0th layer, we'll be using a notation ARR A underscore A 0, 0 plus 0, because as I've said, the layer index along with the row index will form the base address of the row. So a value stored at a displacement of 0 from that particular base address. So here ARR A underscore A 0, 0, 0 will have an alternative representation as asterisk of ARR A underscore A 0, 0 plus 0. Now on generalizing, ARR A underscore A Kij value stored at a jth column of ith row in kth layer, right? So it implies jth element of ith row in kth layer can be represented as ARR A underscore A Ki plus J, right? So this is very simple as in the previous instance, right? So here ARR A underscore A Ki will be the base address of the ith row in the kth layer and value stored at displacement of j from that. Now on simplifying, so what we have done is we have used the notation derived from two-dimensional array. So in case of two-dimensional array, ARR A underscore A Ki can be replaced with asterisk of ARR A underscore K underscore a k plus I. So this is a very simple deduction in case of two-dimensional array that we have come up with, right? Okay, so this is the substitution that we have made. This is the substitution that we have made, right? Okay, so arr a underscore a I k ij can be replaced as replaced with asterisk of arr a underscore a I plus j. So that is what we have done here, right? You see, so arr a underscore a k I can be replaced with asterisk of arr a underscore a k plus I. On further simplifying using the notation derived from one-dimensional array. Now arr a underscore a k can be replaced with arr a underscore a plus k, right? Okay. Now just see, this is the substitution. So eventually, arr a underscore a kij can be replaced with asterisk of asterisk of asterisk arr a underscore a plus k plus I plus j. So first we will make increment in the layers, then increment in the columns, and likewise increment in the rows, and likewise increment in the columns. So this is the way how values of three-dimensional array is accessed. So this is a very important deduction that you need to remember. Now let us move forward and let us learn about pointers and functions. Now, pointers can be made to point to a function. This is very much important statement that one needs to remember. So, pointers can be made to point to a function. So here, whenever we want to make a pointer point to a function, we need to first declare a pointer, right? Okay. So a pointer that is capable of pointing to a function is called as a function pointer. So in order to declare a pointer that is capable of pointing to a function, first we need to specify the return type. Within pair of parentheses, we need to have the pointer name and the parameter list. So here I have declared a pointer. Just see, integer asterisk ptr integer integer. Now it means ptr is a pointer, right? PTR is a pointer that is capable of pointing to a function that takes in two integer parameters and returns an integer value. So this is the way how the pointer declaration is to be interpreted. So here PTR is a pointer that is capable of pointing to a function that takes in two integer parameters and returns an integer value. So here example, so here add is a function that takes in two integer values and returns an integer parameters and returns one integer value. So PTR will be capable of pointing to such a function, right? So again I'll repeat it. So pointer can be made to point to a function, and such kind of pointer is called as a function pointer. So in order to declare a function pointer, we need to know the return type, we need to know the number of parameters that the function takes in order to perform operation. So here we have taken up an example. So here PTR is a pointer that's capable of pointing to a function that takes in two integer parameter and returns an integer value. For an example, integer add integer integer. So here, in order to call the function using a pointer, so here what we do is we use in normal situation, what do we do is we use z is equals to add 3 comma 4. So it will make a call to a function by passing the parameters 3 comma 4. Now, as we already know that in case of a function declaration, the function name marks the beginning of function definition in memory, right? Okay, so function name itself is a pointer value. So in order to make a pointer invoke a function, so what we need to first do is we need to first assign the address of the function to the pointer. So here ptr should be initialized with add, right? This is very much important. So here ptr should be initialized with add. So the function definition can be called using z is equals to add 3 comma 4 or z is equals to, so here just see what we are doing is we are using the pointer notation in order to call the function. So here this is the way how you can use function pointers in order to invoke a function. So asterisk of ptr 3 comma 4. So here it will call a function whose address is being held by ptr, but we need to ensure that ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr is assigned with the address before the call. So here ptr That is, PTR should be initialized with the address of the function, as the function name itself is a pointer value. So this is a very important statement that you need to remember. So a function can be made to point to a pointer can be made to point to a function, but provided that the address of the function is assigned to the pointer. So such kind of pointers are called as function pointers. Now here, the next example that we have is pointers and objects. So here, what we have done is we have, in order to establish relationship between pointers and objects, right? So here what we have done is we have taken up a class date, right? Okay, and it has data members and member functions, right? Okay, so here I have a class date wherein we have the data members as dd mmyy, and then we have a constructor that is capable of initializing dd mmyy to 00, and then I have a member function void get date that is capable of initializing dd mmyy with the value that you want to assign to the day, month, and year. Now after that, you have print data that is capable of printing the value of the dates. That is in terms of ddmmyy, right? Okay. Now here in the main function, what I've done is I've declared an object d1 of the type date, and I've declared a pointer dptr that is capable of pointing to object of type date. Now here what I'm trying to do is I'm trying to initialize the data members using the object. So here I am executing d1.getData 22 2021. So here what it will do, it will initialize 20 to dd, 2 to and 2021 to YY, right? So using the object, I'm initializing the three members of the data members of the object. Then after that, I'm printing the content of the three data members, that is DDMMYY. So it will print the date, that is 22 2021. Then after that, I've assigned the address of the object to the pointer, right? So this is a pointer to an object. So I've assigned the address of the object to the pointer. Now using the pointer, what I'm trying to do is I'm trying to print the date. So what it will do is it will print that is the same date, that is 22 2021. So here I'm using the object to print the date. Here I'm using the pointer instead of object to print the date. Now here what I'm trying to do is I'm trying to initialize the variables ddmmyy using the pointer, right? So okay, so dpr member access operator get data, right? That is 21 to 2021. So here I'm initializing the variables ddmmyy belonging to object d1 with the help of a pointer, and then eventually what I'm trying to do is I'm trying to print the data using the object. So here this is a very simple example that tries to show how objects can be used in collaboration with the pointer in order to access the member function and the data members. So this is a very simple example, so you can go through it and you'll be able to understand what this particular program is capable of doing. So this is the program that tries to show relationship between pointers and objects. So in this class, what we have learned about is we have learned about relationship between pointers and two-dimensional array. We have learned about relationship between pointers and three-dimensional array. We have learned about relationship between pointers and functions. Likewise, we have learned about relationship between pointers and objects. So we'll continue on with the pointers. So for now, thank you very much. Have a very good day.